Okay, so let's go over practice quiz 9. So in quiz 9, you're going to submit it on a Google Doc. So you'll have 4 steps like this. First, that'll be open a Google Doc and name it. On your quiz, it'll be quiz 9, then add your name. Then you'll paste the quiz into your Google Doc. Then you'll answer the questions. Then you'll submit it. Okay, so let me just go down here then. Okay, so I'm going to skip question 1 for now. I'll come back to that. Let's go on to question 2 here. It says, in a population of 250 million people, suppose 60% are in support and 40% are against some issue. We will take 1 to equal support and 0 equal against. Suppose that 400 people from our population were surveyed and asked whether they supported the issue. Suppose further that 15 different surveys of 400 people were conducted. The step below shows results of each survey, where each number in the set represents number of people in survey who support the issue. So just imagine 15 students in our class were each conducting a survey and are asking 400 people and are asking the same questions. And you're going to record their results. If a person says they support, they'll record it as a 1. If a person says against, they'll record it as a 0. So say the first student, their number is 249. That means 249 people in their survey supported the issue, and the next one is 238 for this student, and so forth. So this is an example of a binomial experiment. So let me just define a binomial experiment here and some other things that we're going to need. So an experiment only has 2 outcomes. In this case, it's either support or against. So there's only 2 outcomes. So some examples would be success, failure, heads, tails, yes, no, on, off, 1, 0, true, false, support, against. Let P be probability of success. So here we're considering support as success, say. So here our p-value would be 60%. So 60% are in support. Then the standard deviation, when you have an experiment like this, is the square root of p times 1 minus p. So it's pretty much the square root of percent that support times percent that are against. So the experiment is repeated n times. We call it a binomial experiment. So here, where each person is asking 400 people, so it's repeated 400 times for each person doing the survey, and 15 people are doing the survey. Okay, so we're going to define SE here to equal the standard deviation divided by square root of n, where n is the sample size. Here our sample size is 400. Okay, and we'll have to compute our standard deviation using this formula here in a second. Okay, and our x bar, that's like our sample mean. So that would be adding up all the results of people. So the x1 maybe would be support, that'd be 1. Maybe x2 would be against, that'd be 0. x3 would be support, that'd be 1. So you'd add up all those. So this top part is basically, and this first one would be 249. That'd be the sum of all the x's. We're going to take the average divided by n. So in our case, the n is 400. Okay, and x bar is called the sample mean, and we call z equal to x bar minus mu over SE, the z-score. So here the mu and p are the same. So, okay, let's now start answering the question. So we need to write the R code that does the following: computes the sample means, computes the z-scores, creates a frequency histogram of sample means, the above data, and creates a density histogram of z-scores, and overlays the standard normal curve. So let's start doing this. So let me take my data here and start writing up below over here. So I need that. So I'm going to say R code here. I'm just going to start here. So this got to be part of my R code. Now our p-value in our case is the percent at support. So if you go up there, it was 60%. So as a decimal, that'd be 0.6. So it'd be 0.6. So then in that case, 1 minus p, let's call it so call it q, or call it q, say. That'd be a number that are again, so it'd be 0.4. Okay, and our n value here is 400 because there's 400 in the sample. Okay, let's do our standard deviation then. So we're going to define that to be, so it's a square root, so it'll be in R, you'd write that as SQRT, that's square root of P times Q. So that'd be our standard deviation. Again, I'm using this formula up here to find the standard deviation. Where is it? Right here. So square root of P times 1 minus P. 1 minus P I'm calling Q. Okay, let's find our standard error. So the standard error is defined to be the standard deviation divided by the square root of n. I've already defined my n up here, it's 400. Okay, so we got that stuff. Now let's start finding the just answer part A here. So we need to start finding the sample means. So let's go through and find those. Okay, I'm going to call the first one x1, say the first one first sample mean. So x1 is going to be defined to be, well, that's the first person survey. So the first one, the survey was 249 supported, so it'd be 249. And it was out of 400, so divide by 400. Okay, you're going to separate these by semicolons actually. Then you have x2, go on to the next one. So the next one is 238. So it'll be 238 divided by 400. Then semicolon. Move on to the next one. So x3. So x3 would be, the next one is 225. So 225 divided by 400. Semicolon x3. Sorry, x4. So moving on to the next one. So we did 225, so it'd be 228 the next one. So 228 divided by 400. Then x5. So we're on 241 now. So 241 divided by 400, semicolon. And then I'm just going to repeat these and then make some changes to them to be more efficient this way. So let's repeat them on the line below. So let's call this then x6, x7, x8, x9, x10, and then we'll change. So our last one we started left out was 241. So next one will be 237. It'll be 237 here. The next one will be 253. The 253 goes here. Next will be 243. 243. Next one will be 246. Here, 246. And next one would be 218. Okay, and I have 5 more to go. So let me just paste it again and make changes. So pasting, then it'll be x11, x12, x13, x14, x15, and making the changes here then. So we left off at 218, so it would be then 242 the next one. 242, 219, 260, 243, 243, and lastly 238. Okay, so let's keep going. Okay, so now below this, I'm going to call it sample means. So sample means. And I'm going to define that to be the vector consisting of all my sample means here. So it'll be x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, x11, x12, x13, x13, x14, x15. Should that right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's good. And then what I'll do is I'm going to say print, and then sample means. And below it write sample means. Actually lowercase s, sample means. Okay, so when I run the R code, I'll be able to identify, let's make it capital again, lowercase here, so be careful. Oh, makes it a capital again, well forget it, I'm going to make this guy up here capital and, okay. Right, so let's keep going. So now to do the z-scores, so the z-scores, so if you look up here how the z-score is defined, it's x bar minus mu over SE. This mu here is p in our case. Okay, so let's do z1. So z1 then would be our x1, that's our x bar for this one, minus our p divided by SE. Moving on to the next one, z2 would be x2 minus p divided by SE. z3 would be x3 minus p divided by SE. z4 would be x4 minus p divided by SE. z5 would be x5 minus p divided by SE. And I can just repeat these and make some changes. So I repeat these here. Okay, so it'd be Z6. Well, actually, I'm just about out of time in this video, so I'm going to continue this in part 2. So let's leave it there.